Hello guys. Hello guys. Please let me know, am I audible or not? Am I audible or not? Hello guys. Am I audible or not? Yes, am I audible? So let me start this. Hello guys. Am I audible or not? Yes, am I audible? So let me start this. Hello guys. Am I audible or not? Yes, am I audible? So let me start this. Hello. I don't know. Hello. 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 I don't know why there is a background noise. Hello. Hello. I don't know why there is a background noise. Hello. 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 Am I audible? Hello. Am I audible? Hello. Am I audible? Let me check the filters. Hello. 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 Is the audibility and visibility absolutely fine? Is the audibility and visibility absolutely fine? So let me start today's session. Hello. Hello. Start today's session. Hello. Hello. Okay. First, we check all the things are working properly. If there is something problem, then we will see it later. So, guys, our today's topic, as you can see from the title of the video, is binomial theorem. So now कई लोग सोच रहे होंगे कि बाइनोमियल थ्योरम में क्या पढ़ना है, वो तो हमें पता ही है, उसमें तो सिर्फ फॉर्मूला ही आता है. बट नो, here we are not discussing just only formula. We are discussing many more things beside formula. We are discussing how the formula came from, what's the reason, what the significance of the formula. So okay guys, let's start our today's session. So if you want to make a notes, then you can, or else I'll provide the link in the description from where you can download today's PDF. Okay, so we are starting from a story, then we are move gradually forward to understand the theorem. So let's say we have three coins. So if we know that if we have three coins, then the sample space is, what is the sample space we have? We have h. You can also write in your notebook hht hth ht. Okay, t. Now same ttt tth tht and thh. So as we know that we have 8 outputs. You can see on my screen. Let me increase the thickness of the pen. Okay, now we have to find a probability of what? Probability of two head in three toes. So from the sample space we have to select our requirement, what we want to find. So we know that this will not come. Okay, which contain three head. This will not come. This is also contain three head. This will not come. This will not come. Okay, here t h h. This will not come. So what's we have? We have hht hth thh. I know that it is a very simple thing. We all know that how we have to find it. Okay, so here thh. We know that what's the output? The output is 3 by 8. I think you all got it what I'm trying to say. Now let's say we have not 3 toes, 10 toes. Now many of you thinking that 10 toes, let me do it by myself. Like for 3 coins, if we are tossing the 3 coin, we get 2 raised to 3 equal to 8 output. Now for 10 toys, 10 coins, we get 2 raised to 10, means 1024 total output. From that I'll find 2 heads, and that's very simple process, you know that. No, it's not a simple, it's a very complicated process. So how to solve this kind of question? Means this kind of question means the question in which we have to deal with a large number of experiment. So for this kind of problems we are using a binomial theorem, because in real life we know that we don't have to find these small things like two head and three toes. We have to deal with the number of outputs for that particular event, the number of outputs, like if we are thinking about the changing of price of stocks, the changing of the weather. So for that also, for all kind of that value, we have to deal with a large number of data sets. So for that we can't go manually. We have to use something so that our process or our execution will be very simple. So for that we are using a binomial theorem. So you know that where we have to use a binomial theorem. Now what's the binomial theorem? So okay, so I'll go from this example only, and you will get all the concepts which I want you to learn in this. So if you are not comfortable in English, because I am also not more comfortable in English, so my language is English, means Hindi plus English. So I'll take lecture in both language, means it's side by side parallel. So we can say that here two heads in three toes. So let me write it again. So P, what is P? Two head. Here two head means exactly two head in in three toss. What toss means? Toss means we are tossing here a coin. So what we are getting? We are getting h t plus p of t h h and plus p of h t. Now we know that, what we know that, we know that getting a head in a coin and getting a toss in a coin, both are the independent events, right? So if we have independent event, then we can further write like this: p of h into p of h into p of t plus p of t into p of h into p of h. Now p of h, p of t, p of h. So let's say one thing. So we know that what we are finding here the two heads, means we want to find the two heads. So let's consider finding a head as a success, because we want to find the two heads. So we are taking a finding a head as success and finding a tail as a failure. So let's represent success as a terms of p, failure in terms of q. So let's put the value here. So p into p into q with the q into p into p with the p, okay, into q into p. What means plus? I think I am using the Gujarati also. So we can simplify this as p square q plus q into p square plus p square q. So what we are getting? We are getting 3 p, okay, 3 p square q. So that's our output in terms of success and failure. So this is the only our formula. What we can't get it. So let's express, let's get inside of this formula. Which formula? 3 into p square into q. Okay, so can you see here anything? No, we can't see. Okay, let me tell you what we are getting here. We are getting here p square. What's the p? P is the success for our get event, and what's our event? Our event is getting head, and here we are getting p square. So what we can say about the p square? P square meaning p raised to square. Square is two heads, means p raised to our criteria. So we can write like that: p raised to criteria. X represent the criteria, means we want to get a 2 head. If we want to get a 3 head, then we are getting here p raised to 3, means pq. Okay, now what's q? Q is a failure. So now we can, why we are getting here 1. So let's understand that also here. So let's consider we have uh, a toss a coin and we are getting 5 outputs. Yeah, we know that if we are tossing a 5 coin, we are getting a 5 out, means 5 output, means we have 5 total possibility. Like if we want to find the 3 head, then this is the head, this is the head, this is the head. We are considering only the 3 head, we don't consider what is the remaining. So for n equal to 5, if we are getting a 3 head, and so this is called a success, so this is only a failure. So this is the failure only. Okay, so got it. So if we are thinking about the general form, so if we have a total n, in total n, if we have x number which is represent the success, means here x means the our criteria. What's our criteria? Our criteria is getting 2 head. So what is the power of q? The power of q be n minus x. Okay, got it. So this is the formula that what we are searching for. This is the binomial distribution only. Like you know that we are writing, many of you know the formula. What? B of x into q of x, and here ncx. Now what's the ncx here? So you know that this is the p of x, means the probability of getting a two heads. This is p square. Q means the remaining thing we can consider as a q, and this is the number of way. Okay, number of way means, what's the number of way here? So this is number of way. Like we know that we can get a p square q by how many ways? Like p into q plus q into p plus p into q into p. That's how we can get p square q. So this is the three ways. Or here we saw that we write here ncx. So why we are writing ncx? So let me also clear that doubt also. If we have three alphabet p, p and q, and if we want to make a string from this three alphabet, then what we are doing? We are just doing the thing like a 3 factorial. Total arrangement is the 3 factorial, and these two are same, so dividing by 2 factorial. So what we are getting here? We are getting here 3. This is the same as 3c2. You can check here also. 3 factorial, 3 minus 2 factorial into 2 factorial. Got it? Okay, that's why we are writing what we are writing ncx. So now let me write the formula of binomial distribution with properly. So first, n. What is n here? N is number of trials. Got it? Okay. Now x is our criteria, our full story, or you can say the criteria, full story which we want to find. P is what? P is success for one trial. Q is failure for one trial. Failure for one trial. Okay, we can also write as q as 1 minus p. So these are all the parameters which we are looking for in our formula. So from that, what we can say about the formula? Our formula will be ncx p raised to x q raised to n minus x. So now you will get to know how this formula is coming, because we saw one example here, the two heads in three toes, and if you want to directly solve, you can directly put here value only. These are all the variables which means ये वेरिएबल सब क्या रिप्रेजेंट कर रहे हैं हमने वो भी देख लिया. अब हम कुछ ऐसी बात देखते हैं जो आगे जाके क्वेश्चन में ट्रैप बना सकती है, मीन्स क्वेश्चन को गलत भी करवा सकती है. सो अगर हमें किसी ने बता दिया कि हमें बाइनोमियल कहाँ यूज़ करना है तो हम यूज़ कर लेंगे, पर हमें अपने आप पता कैसे चले कि बाइनोमियल कहाँ यूज़ करना है. सो इफ यू वांट टू मेक इट स्टार्ट, देन यू कैन ऑल्सो डू इट फॉर दिस काइंड ऑफ पॉइंट्स विच आई एम ट्राइंग टू टेल यू. सो फर्स्ट थिंग इज दैट binomial we can use only for output is terms of the two possible values. Means we don't understand. If we are tossing a coin, so what you can get whether the head or tails, not other than that. हम यहाँ पर हम शिवाजी की बात नहीं करता है कि अगर हमने कॉइन टॉस किया तो खड़ा भी रह सकता, नहीं. यहाँ कॉइन खड़ा रहने की बात नहीं है, या तो फिर या तो उसमें हेड आएगा या तो टेल आएगा. अगर हम कोई चीज़ की बात करें, अगर मैंने ये बॉल पेन की बात की, तो ये बॉल पेन या तो चल सकती है या तो नहीं चलेगी. दो ही पॉसिबिलिटी है, या तो ये डैमेज्ड है या फिर ये डैमेज नहीं है. सो अगर हमारे पास कोई दो ही पॉसिबिलिटी हो, then and then we can use here a binomial distribution. Now the second thing is that, so first write only for two kind of possibility. Now what's the second thing? Second thing, let's consider here two kind of possibility. Let's the second thing is that the probability of, we are thinking about the probability of success, then probability of success हर एक इवेंट के लिए सेम आना चाहिए. Means probability means some of you might thinking that the probability of success can change also. Yeah, can also. Let me give you one example. So if we have this basket in which we have red balls and blue balls, okay, so now we have two red balls, no, two, we have four red balls and three blue balls. Now we want to select a red balls, so what's the possibility there? So we can select one red ball from total, and now we select one red ball, so now we have only three red balls, so from 3 and total will also decrease to 6. So that's how we are getting here the number of red balls. So what's our statement? Our statement is that to getting a red ball, so this is also satisfying the success, this is also the success, but we know that the probability of success is here different. Here it's 4 by 7, here it's 3 by 6, or you can simplify to 1 by 2. So we are getting a different probability, so we can't say that this kind of events are called a dependent event. Means if we are removing here one red ball, then then the output of the second red ball will affect. So this kind of event we are not talking in a binomial distribution. So the other thing which we are getting is what? The other thing which we are getting is the event should be let me tell you the other thing in the same question. What's that? The thing is that if here we are doing without replacement, but if this question is asked with replacement, then we can use a binomial distribution, because with replacement here this will be a 4 by 7 again. So do you understand? With replacement this can be possible, but if without replacement then it will be a dependent case, and for dependent case we can't use binomial distribution. Okay, so let me write that thing also here. Event should be independent, so independent event. Now, so if our event is independent, then we are getting only one probability for the success. So for the failure we are getting 1 minus q, and so we can also write like this: p plus q equal to 1. That should be true for binomial distribution. Now the third thing is the value of x. We are taking here value of x. So what different kind of value of x can be possible? So if let me tell you about the binomial distribution. So as we saw previously, the binomial distribution is a real life distribution, so we are using in real life, so we can't say the value of x can be negative. Okay, and also the decimal value can't be possible. So for binomial distribution, the value are discrete random variables. So it's starting from 0, 1, 2, 3, 4, 5 up to infinite. So value of x can't be negative. So let's consider if I am going to buy something on a shop, and then I can't tell the vendor that give me 2.5 banana, give me 1.7 apple. Whether I said 2, 3, 4, 5, 6 in discrete terms also. So for that, because we are dealing with only discrete, so the value of x could be 0, 1, 2, 3 up to infinite. If we are getting a value as infinite, then that's also a different case that we will going to see in further classes. If you like this all the things, then do comment in video. Okay, now so these are the main things that we should have to follow for checking whether we can use here a binomial distribution or not. So what's the thing? The thing is that only two kind of possibility are there. The second thing is that the event should be independent events. So because of we are getting independent, then and then only we can get p plus q equal to 1, and our x should be discrete random variable. Okay, so this is the formula, this is the property of the formula, how where we can use a binomial theorem. Now the next thing is variance or expectation. So this is e of x represent the expectation you can find by method, which you can by find the formula like xp of x that we already know for discrete random variable. This is the formula, but here if we are using a binomial distribution, then there is a formula direct e of x equal to n into p, and the same if we want to find a variance, then the formula for variance is n p cube. Now standard deviation is the just square root of the variance. Now many of you might think we don't believe in your formula, we want an example for the your formula. We how can we believe that you are right or wrong? So okay, let me give you the question. Question is what? So question is we are tossing a coin. Okay, what yeah, we are tossing a coin for three times. So we are, and we want to find the number of heads we are getting. 0 head 1 by 8, 1 head 3 by 8, 2 head 3 by 8, 3 head 1 by 8. Okay, now we want to find the expectation, because many of you know no we want an example for your all of your explanation. We don't want to by heart anything. Okay, e of x, if you will go by formula, which formula? General formula, then what you will give, you got as output. So just try 0 into 1 by 8, 0, 3 by 8, 6 plus 3 9, 9 plus 3 12, 12 by 8 equal to 3 by 2. Now just go with this formula also. So we are tossing a 3 coin, so for that we have n is equal to 3, and p, what's the p is getting a head in one trial. So what's the probability? 1 by 2. So 3 into 1 by 2, what's the output? Output is 3 by 2. Okay, so this is the all about binomial theorem. Now here we are dealing with n equal to number of tiles. Number of tiles are 1 2 3 4, any number of tiles possible, but there is also one related concept with this. What's that? This concept is, let's see, if what happen if n is 1. So when n is 1, the binomial distribution transfer to Bernoulli. Okay, I know my spelling, I don't know also the spelling. Bernoulli distribution, the same formula, the same thing, all the properties also same, but the thing here we are dealing with only n equal to 1, means here the number of tile are 1. So what's the formula? Formula is p raised to x q raised to 1 minus x, because here we have 1. Now expectation np, n is 1, p variance p into q. Here also we are following the same property. Which are the properties we are searching for a binomial distribution? The event are independent. Let me hear properly, the event are independent. The second thing is p plus q is equal to 1, means we are dealing only with two kinds of possibility. And the third thing is our x should be discrete random variable. X can't be less than 0 or in decimal. So yeah, this is all about the binomial distribution. Now with the help of this formula you can solve any kind of question, any kind of way. This is just one part of binomial distribution, that's known as the Bernoulli distribution. Okay, so from starting, if you are checking here, I am telling you the story about the distribution, why this distribution is needed, This distribution is needed for the large number of problem, like if we are giving here the 10 toes, then how will you solve the example? So directly if you want to solve that example, then with the help of binomial distribution you can easily solve that. This is the probability of success, this is the probability of failure. So for one case, this you will get p square into q, but how many different cases you will get? So for this 3, which is a number of variable, we also know that how we are getting the 3 here. 3 you are getting by p into q. The different possibility are 3 factorial divided by 2 factorial, which is a 3, which is same is equal, the 3 factorial divided by 2 factorial is equal to 3, which is same as 3c2, or we can say general ncx. So this is the formula where n is the number of trial, x is the full story, means the what we are want to find. P is the success for one trial, q is the failure for one trial. This is the formula, these are the property which should satisfy binomial distribution. What is that? The only two kind of possibility, it should be independent, the discrete and a variable. This is the formula for where standard this is the formula for the expectation, average, mean, all you can say. This is the formula for variance, and let me write also for standard deviation. Standard deviation is, okay, got it. Now this is one example which prove the formula. This is for if our number of trial is 1, then it's called as the Bernoulli distribution. Now if you want an example, then I can give you. So okay, this is our last example, and then we will end our lecture here. So what's the question? Read the question. I will just write the main point of the question. I don't want to write all the full question. Okay, got it? Okay. So probability of defective piece being produced in a manufacturing process is 0.01. So what's the probability of defective piece produced in manufacturing is 0.01. So okay, this is our one case. Now the probability that out of 5 successive pieces, so we know that n is 5, only one is defective. We also know that x is 1 and 1 is defective. We want to find for defective now. So this probability is for what? This probability is the probability of success, as simple as that. So what's the probability of failure? Probability of failure means 1 minus p, which is 0.99. okay, now first check whether we can use binomial or not. So we can use. Why? We have a 3 condition that we saw previously, so we check here again. We can say that here 2 possibility, defective or non-defective. Our x is a discrete random variable and these 2 are independent. Even if one is defective, then it can't affect the another piece to that it should be defective or indefective, and non-defective, not indefective. Okay, now we can use binomial. We have n, we have x, we have p, we have q. So just put the formula now. Q of x, p raised to x, q raised to n minus x. So what's n? N is 5, x is 1, 5c1, p 0.01, and q is 0.99 raised to n minus x, means 5 minus 1, 4. Now I am not simplifying it. This is the answer of your question. Got it? Okay, now many of you might thinking that no, we don't believe in this, we don't want to use formula, or how can we believe that this is the true answer? Okay, don't believe. Let me give you the another method of this question. What? Another method? Yeah. So what we have to find? We have to find the defective piece 1. We have a total 5 pieces in which we have to select only defective piece which should be a 1. So 1 defective and the remaining 4 are non-defective. Okay, now this could be here also, like in second position we get defective, like that. You have still 3 possibility. D should be here, D can be here, and D can be here. Now these are the different cases. If you are doing the addition of this all case you will get the same answer in previous question. So this is the visualization of the binomial distribution. This is the formula. This is one. Yeah, okay. Now that's all for the today's classes. So if you have any query, you can ask in comment. I'll answer by next lecture, or I'll solve your doubt in next lecture. And if you want this PDF, then from the description there is a link of one website from which you can go and download this PDF. So if you like this video, then just do like it. Now let don't me don't waste your more time. Okay guys, bye. This is all about the binomial theorem. Bye bye.